To measure the density of a liquid, we'll need a graduated cylinder to measure volume, and a scale to measure mass. I put the cylinder on there, it has a mass. Common mistake students make is to assume all cylinders have the same mass. They clearly don't. But I can zero out the mass with this button here, and that allows me to determine the mass of what I put in the cylinder, not the cylinder itself. To measure volume, I'll use a squeeze bottle and I'll read the lines on the cylinder, and I will get 10.0 milliliters right on the line. I have 10.0 milliliters right on the line, so I know the volume is accurate. So now this is the water, and when I put that on the scale, you can see it reads almost 10 grams, which is good. The density of water is 1 gram per milliliter. So if there are 10 milliliters, it should read 10 grams. So I have a small amount of error, not much. On the other side, I filled this cylinder also with 10.0 milliliters, but it's not water. It's methylene chloride or dichloromethane. You can see the mass here is much higher. Equal volumes, unequal masses. The dichloromethane is more dense, a higher density, more grams in the same volume. To calculate density, you need to know mass divided by volume. So in the example, we had 13.17 grams in 10.0 milliliters. And if you divide those two, you get this, 1.32, I'm rounding a little bit, grams per milliliter. That is often expressed this way, 1.32 grams slashes per milliliter. Density of dichloromethane. This is the shorthand for dichloromethane. That's what it is. Density of water, you saw earlier, often written this way, 1.00 grams per milliliter. So I'm now going to mix the two, but I'll add a little color first to the water. And I'll mix it up. All right, great. So I'll put some of the red water in this test tube. There we go. And now I'll add some of the denser dichloromethane. And I think you can see that the denser dichloromethane is going to the bottom. The water is the red part, the dichloromethane is colorless. And so this is a demonstration that the denser substance sinks to the bottom, the less dense substance will be on the top. In some cases, if you have layers of different densities and you shake it, they will mix. But in this case, I can shake it, and you can see they don't mix. They don't mix. They stay as separate layers. Here, I'm going to use ethanol. Ethanol is a lower density than water. And so I'll trickle some down the side here. And here you can see red layer on the bottom is the water, clear layer on top is the ethanol. But now if I shake this one, it won't separate into two layers. they're all just mingled together. So sometimes you can keep two distinct layers like this, and sometimes they'll mingle together. Even though the liquids have different densities, sometimes they'll mingle together.